Hello students, in this class we will learn the application of quadratic equation. Okay, that means the formulation of a quadratic equation and then we have to solve that quadratic equation. Okay, so here we choose a problem. The problem is an aeroplane left 50 minutes later than its scheduled time, and in order to reach the destination 1250 kilometer away in time, it had to increase its speed by 250 kilometer per hour from its usual time. From its usual speed. We have to find that usual speed. Okay, so to formulate this quadratic equation, first of all, we have to write the given conditions. Okay. Solution. Destination. Is 1250 kilometer. That means the distance that plane has to cover is 1250 kilometer. The aeroplane is late for 50 minutes. That is equals to 50 by 60 hours equals to 5 by 6 hours. Okay, already we know 1 hour is equals to 60 minutes. That is why when we want to convert minutes into hours, then we have to divide that minute by 60, and thus 50 minutes becomes equal with 5 by 6 hours. The aeroplane increase its speed by 250 kilometer per hour to reach the destination in scheduled time. The aeroplane increased its speed by 250 kilometer from its usual speed to reach the destination in scheduled time. Okay, so these are the given conditions. Let the usual speed of the aeroplane be x kilometer per hour. So therefore, the schedule time for the aeroplane to reach the destination equals to 1250 by x hours, because the destination is 1250 kilometer and we know speed equals to distance by time. From this we can write speed into time equals to distance, and from this we can write time equals to distance by speed. Okay, by following this relation, time equals to distance by speed, the schedule time for the aeroplane to reach the destination, that is 1250 kilometer, is 1250 by x hours. After reaching, after increasing the speed of the aeroplane, the new speed becomes x plus 250 kilometer per hour. Okay, here to reach the destination in scheduled time, that aeroplane increases its speed by 250 kilometer per hour from its usual speed. That is why after increasing the speed of the aeroplane, the new speed becomes x plus 250 kilometer per hour. Therefore, time required for the aeroplane to reach the destination equals to 1250 by x plus 250 hours. Okay, so when the speed of the aeroplane becomes x plus 250 kilometer per hour, then the time required for the aeroplane to reach the destination, that is 1250 kilometer, is 1250 by x plus 250 hours. Okay, so this time is lesser than this time by 5 by 6 hours, because that aeroplane was late for 50 minutes, and due to the late, that aeroplane increases its speed by 250 kilometer per hour. Okay, that is why this time is lesser than this time by 5 by 6 hours. That is why we can write by the problem 1250 by x plus 250 minus, this time is lesser than this time by 5 by 6 hours, that is this time minus this time is equals to 5 by 6. Okay, so 1250 is the common factor between these two terms, and after taking 1250 as common, the rest of the terms becomes 1 by x minus x plus 1 by x plus 250. that is equals to 5 by 6. We can cancel these 5 and 1250 from the numerators from both sides. So this will give 250. So 250 into the LCM of these two is x into x plus 250, and in the numerator we have x plus 250 minus x, that is equals to 1 by 6. Okay. So 250 into, we can cancel this x, 250 by x into x plus 250, that is equals to 1 by 6. Six two five double zero whole divided by x square plus 250x equals to 1 by 6. By cross multiplication we get x square plus 250x is equals to 62500 into 6. This implies x square plus 250x equals to 375000. This implies x square plus 250x minus 375000 equals to 0. This is the required quadratic equation. Okay. So depending upon these given conditions, we form this equation x square plus 250x minus 375000 equals to 0. Okay. Now we have to solve this quadratic equation by following one of the methods of solving quadratic equation. Okay. Already we know three main procedures of solving a quadratic equation. They are by the method of middle term factorization, then by completing squares method, and then by Sridharacharya's formula. Okay. So by following one of the procedure we can solve this quadratic equation, but this quadratic equation will be more easier for solving if we follow the method of completing squares. Okay. So let us study about the method of solving this quadratic equation by completing squares. Okay. By the method of completing squares, here we have to first of all we have to compare this thing with a square plus 2ab. Comparing x square plus 250x with a square plus 2ab, we get x equals to a, or A equals to x and 2ab equals to 250x. So since A is equals to x, so we can write 2x b equals to 250x. From this, b is equals to 250x by 2x. Cancelling this x and 250 and 2, we get b is equals to 125. Okay. So we have x square plus 2 into x into 125. Now we have the identity a square plus 2ab plus b square equals to a plus b whole square. Already we know this identity. That is why we need a b square here. So b means 125. So plus b square means plus 125 whole square. Okay. Since there is no 125 square present in this equation, that is why we have to balance this by writing minus 125 square. And then the rest of the term 375,000 equals to 0. Now this thing, that is, this is like a square plus 2ab plus b square, which is equals to a plus b whole square. So by following that identity, we get x plus 125 whole square. Now we have minus 125 square minus 375,000. This is minus 125 square minus 125 into 3 into 1000. This is minus 125 square minus 125 into 3 into 1000 means 125 into 8. So minus 125 square minus 125 square into 3 8s are 24. So minus 125 square is the common factor between these two terms, and after taking minus 125 square as the common factor, we have the rest of the term as 1 plus 24. This will give minus 125 square into 25. This is minus 125 square into 5 square. So we can write this as minus 125 into 5 whole square. That is minus 625 square. So thus minus 125 square minus 375,000 becomes equal with 625 square. Okay. Now these are like a square minus b square. Already we know the identity a square minus b square is equals to a plus b into a minus b. By following this identity, we can write x plus 125 plus 625 this whole into x plus 125 minus 625 equals to 0. This implies x plus 750 into x minus 500 equals to 0. This implies x plus 750 equals to 0 or x minus 500 equals to 0. This implies, because product of these two terms, that is x plus 750 and x minus 500 is 0, that is why we can write this equals to 0 or this equals to 0. So this will give x equals to minus 750 and this imply x equals to 500. Okay. So here x represents the usual speed of the aeroplane and speed cannot be negative. That is why we have to discard this value. Since x represents speed, since x represents usual speed of the aeroplane, therefore x not equals to minus 750, imply x equals to 500. So therefore usual speed of the aeroplane equals to aeroplane is 500 kilometer per hour. Okay, so this is the way by which we can solve this quadratic equation. Okay, so when you want to solve a quadratic equation, then always you have to study that problem. That means which method will be better for the solving of that quadratic equation. Okay, so here according to me, the method of completing squared is the best way. That is why we follow the method of completing squares by following this quadratic equation. Okay, so the usual speed of the aeroplane becomes 500 kilometer per hour. Okay, in problem number 2, there are two pipes. Okay, when they running together, they can fill up a tank in 11 hole 1 by 9 minutes. If one pipe takes 5 minutes more than the other pipe to fill the tank separately, then we have to find the time in which each pipe would fill the tank separately. Okay, that means there are two pipes. When they are running together, then they can fill up a tank in 11 hole 1 by 9 minutes. Okay, so between these two pipes, one pipe takes 5 minutes more than the other pipe to fill up the tank separately. Okay, so we have to find the time in which each of the pipe separately can fill up the tank. Okay, so in this kind of problem, here in this kind of problem, here the total amount of water contained in the tank will be contained as one part. Okay, like time and work problem, here first of all we will consider the total amount of water contained in the tank be one part. Okay, so solution. Here we consider total amount of water contained in the tank be one part when it is completely filled. Okay, so first of all, here we consider the total amount of water. Here may be any other different kinds of liquids, but generally our tank contain water. That is why we consider the total amount of water contained in the tank be one part when it is filled, it is completely filled. Okay, since one pipe takes 5 minutes more than the other pipe, therefore there are two different kinds of pipe. One of them is larger diameter pipe and the other one is smaller diameter pipe. Okay, since one of the pipe takes 5 minutes more than the other pipe, that is why we can understand there are two different kinds of pipes and they are larger diameter pipe and smaller diameter pipe. Okay, so larger diameter pipe will take less time than the smaller diameter pipe. Okay, let smaller diameter pipe takes x minutes to fill up the tank separately. Sorry, let larger diameter pipe takes x minutes to fill up the tank separately. Therefore, smaller diameter pipe will take x plus 5 minutes to fill up the tank separately. Okay, since there are two different kinds of pipe, that is why we can consider the smaller diameter pipe will take more time than the larger diameter pipe. That is why we let larger diameter pipe takes x minutes to fill up the tank separately. So therefore, smaller diameter pipe will take x plus 5 minutes to fill up the tank separately. Okay. Now, in x minutes, smaller diameter pipe can fill up one part of the tank. Okay, because as we consider the total amount of water contained in the tank is 1 part when it is completely filled. That is why in X minutes smaller diameter pipe can fill up 1 part of the tank. So therefore in 1 minute smaller diameter pipe can fill up less part of the tank, and according to unitary method less means divide. That is why in 1 minute smaller diameter pipe can fill up 1 by x part of the tank. Okay. Again in x it will be x plus 5 because smaller diameter pipe takes x plus 5 minutes to fill up the tank separately. So this will be x plus 5. So now in x plus 5 minutes smaller diameter pipe can fill up 1 part of the tank. So therefore in 1 minute smaller diameter pipe can fill up 1 by x plus 5 part of the tank. Okay. So this will be x plus 5. Again in x minute larger diameter pipe can fill up 1 part of the tank. So therefore in 1 minute larger diameter pipe can fill up less part of the tank. So less means according to unitary method divides. That is why in x in 1 minute larger diameter pipe can fill up 1 by x part of the tank. Okay. So when both of the pipes running together, then in 1 minute they can fill up 1 by x plus 5 plus 1 by x part of the tank. Okay. So when both of the pipes running together, then in 1 minute they can fill up 1 by x plus 5 plus 1 by x part of the tank, because in 1 minute smaller diameter pipe can fill up 1 by x plus 5 part of the tank, and in 1 minute larger diameter pipe can fill up 1 by x part of the tank. Okay. So when both of the pipes are running together, then in 1 minute they can fill up 1 by x plus 5 plus 1 by x part of the tank. Since in 11 whole 1 by 9 minutes that is 100 by, that is in 100 by 9 minutes. According to the question, when both of the pipes are running together, then they can fill up the tank in 11 whole 1 by 9 minutes. That is why since 11 since in 11 whole 1 by 9 minutes, that is in 100 by 9 minutes, both the pipes can fill up the tank when they are running together therefore the total amount of water contained in the tank in 100 by 9 minutes is equal to 100 by 9 into 1 by x plus 5 plus 1 by x part of the tank. Okay, since in 1 minute both of the pipes when running together can fill up 1 by x plus 5 plus 1 by x part of the tank, therefore in 100 by 9 minutes they can fill up 100 by 9 into this part of the tank. Okay, by the problem, so this part, that is the total amount of water contained in the tank in 100 by 9 minutes is equal to this. So this amount of water in the tank will be equals to 1 part. So this imply 100 by 9 into the LCM of the denominators is x plus 5 into x, and in the numerator we have x plus 5. This is equals to 1. So this imply 100 by 9 into 2x plus 5 whole divided by x square plus 5x equals to 1. This imply these are the fractions. So Product of two fractions equals to product of the numerators divided by product of the denominators. That is why we have 200x plus 500 whole divided by 9x square plus 45x equals to 1. Nothing is present in the denominator means 1 is present. By cross multiplication, we have 9x square plus 45x is equals to 200x plus 500. So we have 9x square plus 45x minus 200x minus 500 equals to 0. So we get 9x square minus 155x minus 500 equals to 0. This is the required quadratic equation. Okay. So depending upon this given condition, we form this quadratic equation. Okay. So here, the first of all, we have to consider the total amount of water contained in the tank be 1 part. Okay. And then by following these conditions, we form this quadratic equation. Okay. So this is our required quadratic equation. Now we can solve this quadratic equation by following middle term factorization, or by following completing square method, or by following Sri-Zaracharya's formula. Okay. So here the procedure of middle term factorization will be much easier. Okay. That is why to solve the quadratic equation, nine x square minus 155x minus 500 equals to 0, we can follow the method of middle term factorization. Okay. So according to middle term factorization, we have to represent the coefficient of this linear term, that is 155, excluding its sign, by the difference or addition of two numbers. And how we get those numbers? Now, that is why first of all we have to find the product of the coefficient of the square term and the constant term, excluding its by excluding their sign. Coefficient of the square term equals to 9. The constant term excluding sign equals to 500. Their product equals to 9 into 500 equals to 4500. Now we have to find two such factors of 4500 whose addition or subtraction will give this 155. Now, if we choose these two factors, that means 25 and 180, then their difference will give 155. That is why we can write 9x square minus of 180 minus 25 whole into x minus 500 equals to 0. This implies 9x square minus 180x plus 25x minus 500 equals to 0. This implies 9x into x minus 20 plus 25 whole into x minus 20 equals to 0. This implies x minus 20 whole into 9x plus 25 equals to 0. So this implies x minus 20 equals to 0 or 9x plus 25 equals to 0. This implies x equals to 20. This implies x equals to minus 25 by 9. Okay. So by middle term factorization, we get these two factors. They are x minus 20 and 9x plus 25. And product of these two factors is 0. That is why we can write this is equals to 0 or this is equals to 0. And after solving these two linear equations, we get x equals to 20 and x equals to minus 25 by 9. Okay. Since x represents the time in which larger diameter pipe can fill up the tank, so time cannot be negative. That is why we have to discard this value. Since x represents time, therefore x not equals to minus 25 by 9 imply x equals to 20. Okay. So therefore larger diameter pipe will take 20 minutes and smaller diameter pipe will take x plus 5, that is equals to 20 plus 5, that is equals to 25 minutes when they separately fill up the tank. Okay. So this is the way by which we can form a quadratic equation and then solve that quadratic equation. Okay. So here we solve this quadratic equation by following the method of middle term factorization. Okay, if you have any kind of doubt, then you can follow the factorization video. Okay, and then if you feel more doubts, then you can comment me in my box. Okay. In problem number 3, we have at t minutes past 2 p.m., the time needed by the minutes hand of a clock to show 3 p.m. was found to be 3 minutes less than t square by 4 minutes. That means minute hand of a clock when crosses t minutes after 2 p.m., that means after attaining 2 p.m., minutes hand clock some minutes hand covers minutes hand crosses some distance which is represented by some minute. Already we know when we follow a clock. Okay, so that minute is represented by t, which is when added with this time, that means 3 minutes lesser than this time, then the clock will show 3 p.m. Suppose this is a clock, when minute hand is in the 12 and this hour hand is at 2, then this clock shows 2 p.m. Okay, now this clock hand is suppose this minute hand is suppose here. So this is the distance covered by this minute hand after showing 2 p.m. and here this distance is represented by t minutes. Okay, so when this minute hand will be again at the 12, then this hour hand will be at this 3, and then we can say this clock shows 3 p.m. Okay, so this time, say this is the position of the minute hand when it passed t minutes after showing 2 p.m. Okay, and again this minute hand when move this further distance, that means when this minute hand when will move this more distance, then we can say this clock will show 3 p.m. That means to show 3 p.m. minute hand has to move this distance by some time, which is according to the problem t minutes lesser than t square by 4 minutes. Okay, so this is our problem. Our problem when represented diagrammatically, then this will be its diagrammatic form. That means when the minute hand in this place is in this place, that is when this minute hand shows t when this minute hand covers these t minutes after showing 2 p.m., then it has to further move this distance by this time to show 3 p.m. Okay. Again, the time interval between 2 p.m. and 3 p.m. is 1 hour, that is equals to 60 minutes. Okay, that is why solution. That is why by the problem we can write t plus t squared by 4 minus 3 is equals to 60, because this time is already covered by the minute hand after showing 2 p.m. and this is the this is the rest of the time for the minute hand when it shows 3 p.m. Okay, and this rest of the time when added with this t time, then we will get this gap, that is the difference between 2 p.m. and 3 p.m., which is equals to 60 minutes. So after simplifying this, we get 4 becomes the LCM, because nothing is present in this denominator and this denominator means 1 is present. That is why the LCM of 1, 4 and 1 is 4. And after addition and subtraction simultaneously, we get 40 plus t square minus 12 equals to 60. This implies t square plus 40 minus 12 equals to 240. This implies t square plus 40 minus 252 or minus 12 minus 240 equals to 0. So this implies t square plus 40 minus 252 equals to 0. This is the required quadratic equation. Okay, so this is the way by which we can form this quadratic equation depending upon this given condition. Okay, and in this kind of problem, when we want to form a quadratic equation, then if we follow this diagrammatic method, then it will be very much easier to form that equation. Okay. So we can form this quadratic equation by following middle term factorization or by completing squares or by following Sridharacharyya's formula. Okay. So here, according to me, by completing square method will be the easier way. Okay. T squared is like a squared and this 40 is like 2ab. So that is why we compare t squared plus 40 with a square plus 2ab, which imply a equals to t and 2ab equals to 40. This imply 2 into t into b equals to 40. This imply b equals to 40 by 2t. Cancelling this, we get b equals to 2. Okay. So, t square plus 2 into t into 2, and to form this identity, that is a square plus 2ab plus b square equals to a plus b whole square, we need a b square here. Here b means 2, that is why we have to write 2 square here. Since there is no 2 square, that is why to balance this we have to write minus 2 square. Then the rest of the term minus 252 equals to 0. This is like a square plus 2ab plus b square, and which is equals to a plus b whole square. That is why we can write t plus 2 whole square minus 4 minus 252 equals to 0. This implies t plus 2 whole square minus 256 equals to 0. This implies t plus 2 whole square minus 16 square equals to 0. This implies this is like a square minus b square, which is equals to a plus b into a minus b. So, by following this identity, we can write t plus 2 plus 16 whole into t plus 2 minus 16 equals to 0. This implies t plus 18 whole into t minus 14 equals to 0. This implies, so this quadratic equation becomes the product of these two. This implies, and this product is equals to 0. That is why we can write t plus 18 equals to 0 or t minus 14 equals to 0. This implies t equals to minus 18, and this implies t equals to 14. Okay. Since t represents time, so t not equals to minus 18, therefore t equals to 14, and this is the answer. Okay. So this is the way by which we can solve this quadratic equation. Okay. So in this class we learn how we can form a quadratic equation, and then we have to then how we can solve that quadratic equation in more easier way out of those three main procedures. Okay.